Now this looks like a very standard sort of question here. We see what is the equation of a normal. And this goes back all the way to AICE 1, and it just says it's a circle, so we know we just have an equation. They've certainly given us some information about this. They've told us a centre, they've told us a radius, so we know we can find the equation. And also they've told us a point where we need to find the equation of the normal. So in our minds now we should be thinking, what information do we need to find that equation of a normal? Well, I need a point, which they've given me. I need a slope. How do I find that? I'm going to differentiate and then plug in the appropriate value. So it seems like we've got all the information that we need. But there is one slight difference with this question, as you'll see once we start to write down what the equation is. So as the centre is 0, 0, I can just put x squared plus y squared. And then the radius is 100. And then one big difference straight away. Normally our equations start with y. And actually for this equation, we've actually got a y squared. So this is actually called implicit differentiation. We're actually going to differentiate two different letters at the same time. Now for x squared, that's just your normal differentiation that we're going to do here. So this would just be 2x. Now for y squared, we're going to do the same thing. We're going to bring the power to the front, decrease the power by 1, which gives us 2y. But whenever we differentiate something with a y, we're going to put dy by dx. And the differential of 100 is 0. Now this looks very strange to begin with, but actually you've been doing this all along, you just haven't even realised it. So if we have something like y equals x squared, when we differentiate, the differential of x squared is 2x. And normally we just write dy by dx straight away without even thinking about it. Really the differential of y is 1, because it's 1y, times by, as we did a y, dy by dx. And then 1 times dy by dx is just dy by dx. So you've actually been doing implicit differentiation the whole time, you just haven't realised that's what you're actually doing. So any questions that have the y variable in it, then we're just going to put dy by dx after we do the differential. Now we can rearrange this, so I can bring the 2x to the other side to get negative 2x, and I can divide both sides by 2y, and therefore I can find out what dy by dx is. And of course I need the slope if I'm going to find out what the equation of this normal is. So negative 2x over 2y, the 2's will cancel, and then we can plug in the information that we need. We know it goes to the point 6, negative 8, so x is 6, so we get negative 6, y is negative 8, and then negative 6 divided by negative 8 is 3/4. Now remember dy by dx though tells you the slope of the tangent, so the slope of the normal is actually going to be the negative reciprocal of this, so in other words negative 4/5. And to find the equation of the normal then, I just use the point slope formula. Y minus the y value equals the slope, doing the negative reciprocal from here, x minus the x value. Now we'll look at the first part of this question. This is from page 147, number 6, and we're given this equation here, sorry. And the first question asks about when does it cut the x-axis and when does it cut the y-axis. So a very common question, x-intercepts, y-intercepts. So it cuts the x-axis when y equals 0. So if we substitute 0 into here, we just get x squared equals 1. So in other words, 1 or negative 1. If we do the reverse, if we want to find when it cuts the y-axis, set x equal to 0, we get negative y squared equals 1. Divide both sides by negative 1. Y squared equals negative 1, and then when we do the square root, we get square root of something that's negative. So in other words, not a real solution, so never for that one. So there are no y-intercepts. Now for part B, we're asked what type of values we can take for this question. Now we've got to be a little careful with this one. This one's rather strange. So we can have values that are greater than 1. So if we have something that's greater than 1, we can definitely subtract something that will give me 1. Now also if I did negative, anything that's less than negative 1, so like negative 2, negative 3, when I square those values, they're going to be something that's bigger, so something like 4 or 9, and then I can certainly subtract something to give me 1. Now what I can't do though is, if I manage to get this as like 0.5, there's nothing I can subtract from 0.5 that will give me 1. Now I could end up with negative 0.5, 0.5 take away negative 0.5 will give me 1. The only problem is this is y squared, so automatically when I square something, it automatically ends up positive. So for that reason, I can't have anything between negative 1 and 1. Now there's no such problems for y. Y can take any value it likes. So there's no such restrictions on that one. We'll always manage to get to 1. I can make this number as big as I like, and I can easily subtract a number to give me 1, so that would work fine. Part C goes back to something from a long way in x1. It asks about even and odd functions, really. We're asked to check if something is symmetric. So if you want to check if something is symmetric, then you substitute in negative x and see if you end up with the same thing. And you do indeed for that first one. And the same for the second one, actually. If you substitute in negative y for y, you end up with the same answer, which tells you it's symmetric about the x-axis. Then we get on to our implicit questions. Oops. Move it this way. So it asks you to differentiate. So as we differentiate something that had a y in, I put dy by dx, and I'll let you check the rest of those answers. Now I'm going to go back to part B for a second. I'd like to give you another way of thinking about this question, which is slightly more algebraic. So I've got x squared minus y squared equals 1. And now we're asked to consider which x values we can take. So what we're trying to do is solve for x here. So we end up with that equation, and we can see that what we have there is we have a square root. So we know that square roots can't actually be negative. So therefore we need to make sure that all this is positive. Now actually we know that if we take a y value and we square it, that will also be positive. So 1 plus anything that's positive is going to still remain positive. So actually for this question, I can plug any y value in here and I like, and I'm going to be able to find the corresponding x value, which is actually the second part of my answer. Now if I do the reverse, but this time what I'm going to do is I'm going to solve for y, so what I end up with is x squared minus 1 equals y squared, and therefore the square root of x squared minus 1 equals y. Now for this to remain positive, so I can do the square root of this, that means that x squared must be greater than 1. This goes back to our quadratic inequalities. There's actually two answers to that question. So we can either have x is greater than 1, or we can have x is less than negative 1. And actually I can allow to have 1 as well, because 1 squared minus 1 is 0, and then you can do the square root of 0. And you can see that that gives you the second answer that we had earlier. So perhaps the algebraic approach might be slightly better than the sort of ad hoc method I used previously.